Use Newton's method to approximate the root to f of x is equal to e raised to the 2x power and then plus 5x. Make it accurate to 6 decimal places. Use x of 1 equals 0. All right, so first step here is to determine what f prime of x is going to be, because we're going to need to use that in our formula for Newton's method. So the derivative of e to any exponent is e to that same exponent, so 2x, but then we have to apply the chain rule and find the derivative of 2x, which is just 2. And then we're going to add to that the derivative of 5x is 5. We can simplify f prime of x to be written as 2 times e to the 2x and then plus 5. All right, so now we have our derivative and we have our original function and we have our first x value that we're going to substitute in there. And Newton's method states that x sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. So our x2 will be equal to x1, which is 0, minus the function evaluated at 0, so that'll be e to the 2 times 0 plus 5 times 0 divided by the derivative evaluated at 0, so 2 e to the 2 times 0 plus 5. All right, so that's going to be 0 minus, well, 2 times 0 is 0, and e to the 0 is 1. So that's 1, and 5 times 0 is 0. So our numerator here is just going to be 1. And then 2 times e to the 0 is 1. So 2 times 1 plus 5 is 7. So we'll get negative 1/7 as our x2. Now to make this easier as we move forward, let's actually start using our calculator here. So if we switch, we already know we have negative 1/7 as our second x value, but we want that as a decimal to make it easier to plug in. So now what we can do to get Newton's method to become more accurate each time is to now use the answer in our formula. So answer minus, we're going to have open parenthesis, we have e raised to the 2 times the answer, and then we have plus 5 times our answer divided by, open the parentheses, we have 2e to the 2 times the answer again, and then just plus 5. And then if we close that parenthesis, now we evaluate, and this is a little bit more accurate. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, we're still not at the same one, so let's evaluate it again. Okay, we still have a little bit of a change. Okay, here we go. 1, 2, 3, 4, 5, 6. This is where it started to level out. So that's at answer choice A, negative 0.148583 is our answer here.